This is Algebra 2, Unit 2, Lesson 3 on function composition. What this lesson is going to be talking about is combining functions. So you're going to take an input and get an output using one function, and then take the answer that your output is and plug it in as the input to a second function. So you're taking an input to get an output, and then using the output as another input. So that's composition. So you're taking two functions and putting them together. So let's take a look at this exercise to kind of demonstrate what that means. A circular garden with a radius of 15 feet is to be covered with topsoil at a cost of $1.25 per square foot of garden space. So in order to figure out the cost of covering the garden with topsoil, the cost is in per square feet, but do we know the square footage? No. We have to know what the area of the garden is first. So remember, area from geometry is pi r squared. So we have the circular garden with a radius of 15 feet. So it's going to be pi times 15 squared, which is 225 pi square feet. And that's approximately, to the nearest square foot, if you put that in your calculator, approximately 707 square feet. So if that's 707 square feet, now that we know it's in square feet because the cost is $1.25 per square foot, we can take this answer, 707 square feet, multiply it by $1.25 per square foot. Notice the units cancel out, multiply them out, and you end up with about $883.75. So in order to answer part B, we had to use the function of area and then figure out the square footage, and then plug the square footage into the cost. So that is taking one function and plugging it into another function. So the output of an area is using the input of a cost. So if we look at how this works with F's and G's, we have an input of X, we put it into a function of F, the output from F becomes the input to G, and then you get your final output. So you get an X into one function, take the answer, plug it into another function. That's pretty much what composition is. All right, now composition is notated in two different ways, and I'm going to show you both ways. All right, we have two functions here. We have f of x and we have g of x. And find values for each of the following. All right, now the first method that you see is written in parenthesis form, function form. So first one is in function form, f of g of 1. When you have the double parentheses like this, what you have to do is you do this first. What's inside the parentheses you do first. So g of 1. Okay, now remembering our function rules, which function do they want us to use? They want us to use g. So we're going to take this function right here. What are we going to plug in as the input? We're going to plug in 1, because to take the function g of 1, when x is 1 in the g function, 2 times 1 plus 3 is 5. So g of 1 is equal to 5. Now, if I have f of g of 1, I'm going to take this answer, f of g of 1 is 5. So f of g of 1 is 5. We take the f function and plug in a 5. 5 squared minus 5 is 25 minus 5, which is 20. So f of g of 1 is actually equal to 20, and we've got it. So when you have the double parenthesis method, you work from the inside out. So let's try one more of those. G of f of 2. All right, which function do I want to use first? Well, I start inside the parentheses. I want to do f of 2 first. So I'm going to use the f function and plug in a 2. I get 2 squared minus 5, which is 4 minus 5, which is negative 1. And then I'm going to take g of negative 1, because f of 2 is negative 1. This goes in here. So g of negative 1, I want to take the g function, this one, plug in negative 1. 2 times negative 1 is Negative 2 plus 3 is 1. So at g of f of 2 is equal to 1. And that's your final answer. Okay, so that's the double parenthesis method. I'm going to skip C for a second. All right, the other method you may see is this little circle right here. That's composition. We talked about composition back in geometry when we did transformations a little bit. It's when you put two functions together to do a composition. Now the tricky part about this is when you're doing a composition, the one on the end is done first. Okay, so when you see f of g of negative 2, this is the same, and if you're doing in parentheses, as this, f of g of negative 2. You do the second one first, and then do the other one. I didn't invent this notation, but this is how it's done. So you do this one first, and then take that answer and plug it in this one. So these two right here are equivalent. So we do it the same way we just did it. We have to do g of negative 2 first. So that means take the g function, plug in negative 2. 2 times negative 2 plus 3. Negative 4 plus 3 is negative 1. And then take f of negative 1, because we're taking this, plugging it in here. F of negative 1, plug in negative 1 squared minus 5. Negative 1 squared is 1 minus 5 is negative 4. So f of g of negative 2 is negative 4. All right, so g of f of 3. Following the composition, which one do we do first? We do the f function first, because g of f of 3 is the same as saying g of f of 3. So f of 3 is first, would be 3 squared minus 5, which is 9 minus 5, which is 4. And then take that answer, g of 4, because the answer, or the output here becomes an input, g of 4 is 2 times 4 plus 3, which is equal to 11. So that means g of f of 3 is equal to 11. Okay, now these last two, c and f, see if you can figure those out, and we'll go over them in class the next time we have class. And we'll move on to the next stuff. So work those two out and see what you get. Now composition can also be done graphically. The graphs below are the functions y equals f of x and y equals g of x. So this linear function is f of x, and this quadratic function is g of x. So we want to evaluate these functions based on these two graphs. So let's take a look at the first one, g of f of 2. All right, so the function we want to look at is, first, would be the one in the parentheses, f of 2. So we're going to do this one first. F of 2. Now remember, when we're doing function notation graphically, we want to know the y value when x is 2 on this function. So if we look at our function, f function, go to x equals 2, what's your y value? 1, 2, 3. F of 2 is equal to 3. Then we want to take that output and make it an input on the g function, so g of 3. So on this graph, the g function, when x is 3, 1, 2, 3, y is 1, 2, 3 as well. So g of f of 2 on this is equal to 3. And that's your final answer. Now you can also do it as f of g of negative 1. Which function do we start with first? G of negative 1 is first because it's inside the parentheses. So I want to start with this function at negative 1. Here's negative 1, 1, 2, 3, 4, 5. So g of negative 1 is negative 5. And then I want to take the f function using the output here as negative 5. This function, 1, 2, 3, 4, 5. Y is about negative 1/2, I believe it is. So that means f of g of negative 1 is equal to negative 1/2. Okay, all right, how about the other function notation? G of f of negative 2. I want to do which function first? Remember, in this notation, the second one's done first because this is equivalent to g of f of negative 2. So I want to look at the f function of negative 2. All right, that's this one. The y value would be 1. And then take the g of 1. G of 1 is this function, 1, 2, 3, is equal to 3. So f of negative 2, I should fix this. F of negative 2 is equal to 1, and then the 1 became here. So g of f of negative 2 is equal to 3. It seemed to like 3's today. All right, let's do one more example, f of g of 0. F of g of 0, we have to do the g of 0 first. So it's this function at 0 is 0. And then take that output and plug it into f. And then f of 0 is equal to 2. So f of g of 0 is equal to 2. Okay. All right, your turn. Try C and try F, and we'll go over those in the next class. Okay, now here's a little more complicated stuff. On occasion, it's desirable to create a formula for the composition of two functions. We will see this facet as we study functions. So what we're going to do is we're going to take one function and plug it into the other. All right, so if we have f of x is equal to 3x minus 2, and g of x is equal to 5x plus 4, we want to determine formulas in simplest y equals ax plus b form for these functions. So basically, we're combining the two linear functions to make another linear function. So this one says f of g of x. I'm going to take the g of x function, and I'm going to plug it into f of x. So that means that's going to be the f function. Instead of writing x, I write 5x plus 4 minus 2. Okay, because this is g of x right here, is plugged into f. All right, when I simplify this, I get 15x plus 12 minus 2. Combine your terms. So f of g of x is equal to 15x plus 10. So there's the composition of those two functions. All right, g of f of x. This one says take f of x, plug it into the g function. So g of f of x is going to be 5 times f of x, 3x minus 2, plus 4. So 15x minus 10 plus 4, simplify your terms, is g of f of x is equal to 15x minus 6. Okay, try exercise 5 yourself and see if you can get the answer. And that is the end of the notes for today. We'll finish the other ones in class tomorrow.